Well, what's up guys, and welcome to the second video on momentum and elastic collisions. And my iPad just crashed, but there we go. So welcome back to the second video on momentum and elastic collisions. Okay, so I know I said that there's only going to be one video, but it turns out that I lied and there's going to be a second one, but hopefully this video should be quite short. I just saw a very interesting concept that I thought I should introduce to you guys, just so that if it does come up in an exam or test, it doesn't catch you guys out. Okay, so basically I want to try and link kinetic energy and momentum P. So first what I'm going to do is I'm going to say write EK in terms of P. Okay, so basically we know that momentum is equal to mass times velocity, and EK is equal to a half mv squared. Okay, so we can also write this as EK equals a half mv times v to get the v squared, right? And there is our momentum term. So we can say that EK equals a half times the momentum times the velocity. Okay, we can also look at this in another way if we wanted to keep the mass term, to keep m. Okay, so we know that momentum equals mv and EK equals a half mv squared. Okay, so I want to get this v squared term, right? So I'm going to square this entire term. So then I'm going to have mv squared, so m squared v squared, which is also equal to p squared. Okay, and basically what I have now is I still need this 2, and I've got an extra m at the top. Okay, so I need to get rid of that m with an m at the bottom. So these two things are now equal, okay, because half mv squared is equal to 1 over 2 mv squared times m over m, right? So these two cancel and we're left with the same thing. So the term on the left is equal to the term on the right, which is equal to momentum squared over 2m. Okay, so that's another way we can write it. So momentum squared over 2m. Okay, now I want to secondly write momentum in terms of EK. Okay, so I already know that EK equals a half momentum V, so I can say that EK times 2 divided by my velocity is equal to momentum. That's from this part right here. And if we look at the second part, we can say EK equals momentum squared over 2m. So momentum is equal to the square root of 2MEK, equals square root of 2MEK. Okay, cool stuff. Now I just want to do an example. Okay, so we have a tree. Let's see if I can draw a nice tree for us. Okay, so let's do an example. Okay, so we have a tree with some which has apples in it. Okay, so one of the apples, we have a small apple and we have a very big apple. This apple is huge. Okay, so I'm going to label this A and label this B. So the mass of A is greater, or no, is less than, the mass of A is less than the mass of B. Okay, and they fall from the same height. Height of A, let's just say there, height of A is equal to the height of B. Okay, and when they hit the floor, their momentums are equal. So at the bottom, momentum of A is equal to the momentum of B. Okay, so this is all given information. So everything I've written is given so far. Okay, and the question is basically at the bottom, is the kinetic energy Ek of apple A greater than, less than, or equal to the kinetic energy of apple B. Okay, so basically the question is, we've got three options, 1, 2, 3. Ek of A is greater than Ek of B. Ek of A is less than Ek of B, or Ek of A is equal to Ek of B. Okay, so we know that the momentums are equal, right? So momentum of A is equal to the momentum of B. Okay, that means the mass of A times the velocity of A is equal to the mass of B times the velocity of B. Okay, but we know that the mass of A is less than the mass of B. Therefore, the velocity of A must be greater than the velocity of B. Okay, that makes sense, because if the mass of A is greater than the mass of B, then we need if the mass of A is less than, if the mass of A is less than the mass of B, then we need the opposite to happen for the velocities. The velocity of A must be greater than the velocity of B. Okay, and we also know from what we just did that Ek is equal to, what did we say it was? A half times the momentum times the velocity. Okay, and in this case, we know that the momentum of A is equal to the momentum of B. So Ek, because the momentums are the same, Ek is proportional to the velocity. So basically, if the one with the higher velocity, because these two terms are the same for A and B, everything is dependent on the velocity. So the velocity of A is greater than the velocity of B. Therefore, we can say that the kinetic energy of A is greater than the kinetic energy of B. Okay, so I hope that makes sense to you guys. So basically, if we have a rundown of the question, we've got two apples. The mass of A is less than the mass of B. Therefore, the velocity of A must be greater than the velocity of B from our momentum condition that was given to us right there. And then what we say is that Ek is directly proportional to the velocities, and so we can say that the Ek of A is greater than the Ek of B. Okay, so the answer is A. Okay, so I hope that made sense to you guys, and thanks for watching.